1,000 and 10,000. I'm just guessing, okay? Yeah. Okay, here there is a problem because with this parameter guess, basically I got infinite values in the simulated river flow. So, of course, this is not a good thing. Let me see, maximum of QoS is 41. Let me see. Because also I don't remember if K is expressed in time or 1 over time. Let me see. Okay, it seems that it's expressed in 1 over time. So this is the plot. The plot is not really good because you see that the observed is at the dots. And the simulated is given by the black line. First of all, let me change the code and put the simulated in red, because otherwise it's difficult to read. So, let me change the code here, and then plot Qt equal red, and also let me put the line width equal to 2. Okay. I need to, of course, to reload the software, and if I run it again, now it should be more readable. Yeah. Okay, you see that it's not really a good simulation. We need to change the parameters, and let me try just by chance, just by a trial and error. It's difficult to move forward with a trial and error procedure when you have 5 parameters, but let me try. And just a few attempts. And let me see if I reduce, it doesn't change much. Let me see now if I reduce these. Now it's better. I reduced the K values, just the last 2, and now it's a bit better. You see that it's improving. There is one other thing to say, that these dots make the graph not easily readable. I think it's better if the black dots are substituted with a black line. So let me go in the code again, and not points but lines. Okay, and now let me reload it, source, and then let me run it again. Now it should be more readable. Yeah, you see that it's not so bad. You start seeing that the red line is, in a way, following the hydrograph, but still we need some improvement. And let's see. If I put 1 over 100 here, didn't change much. Okay, now it's a bit too spiky. Let me see. Okay, we are getting closer. And let me see. Okay, of course now to move forward with a trial and error procedure is difficult, but you know, it's not so bad. And you would be ready now, or you are ready, not would be, you are ready now to try yourself with the automatic optimization, because we already did with the time area model, and you can do it with this one, no problem. The only thing you have to be careful in the definition of the parameter range, because this is important. So what you need to do when you define the parameter range is start from this situation, and these are already values for the parameters that are reasonable, and then take around these values a wide range. So basically what I would suggest you to make is, instead of giving 400 for the first parameter, I would give as limit 100 and 800. For beta, I would give 0, 1. For alpha, 0, 1. And the tricky parameters are the last 2. I would give a range of 1 1 over 100 for the first, and 1 over 1000 for the second. And you have to try. After the optimization, if you see that one of the parameters assumed a value that is the same as the limit of the range, then you have to extend the range. Because, you know, if you get a parameter that is sitting on the limit of the range, it means that the range was wrong. You have to extend the range. Okay, that's it. Sorry for, you know, I understand that first I made some confusion at the beginning. I hope you managed to, because I didn't remember how to make the selection of the vectors, of the elements in the vectors. And please pay attention to what I did, because it's extremely useful in R to be able to select given elements within a vector by using the conditions between square parentheses. Second, for the code, unfortunately I had to rush, because otherwise spending time on each line of the code would require like, you know, 5 hours to get through it. But what I would like to suggest to you is to go through it, and then if you have questions, next time we can solve them. Okay, see you on Monday.